Now we are going to discuss this problem number 29 mentioned over here. Show that the right circular cone of least curved surface, that is minimum curved surface, and given volume. When I say given volume, I say the volume is fixed, you can't change it, it's a constant. Has an altitude, that is the height, equal to root 2 times of the radius of the base. So this is what we are going to discuss now. Now you consider a cone. So as you know, the dimensions of the cone are the slant and your height and your radius, and the relation between them is, as usual, L square is equal to h square plus r square, isn't it? Now we have been given it's of fixed volume. Your volume is fixed. So what is the volume of a cone? Pi by 3 pi, that is r square, h is a constant value. So we have a relation that's been specified at the beginning itself. Your volume is given, that is it's fixed, it's a constant. So what is to be done is you have to show that the curved surface area, so your curved surface area, it's namely S pi RL, is least when your height is root 2 times of your radius. So that is what the question is. So now we are going to go about it. So S is equal to pi RL. So what is the relation that you have between L, H and R? So this is pi r into square root of h square plus r square. So for differentiation purposes, it's better you have this root eliminated. We can make it as square, you name it as a, the square of the surface, that is pi square r square into h square plus r square. So in this way you can easily handle your differentiation instead of handling with this root. Because when a square is minimum, automatically your value is going to be minimum. So you can just specify it. So your S is minimum, or what do you call, otherwise is least, if A is minimum, the square is minimum. So now we are going to start with your process of differentiation in order to get it. So now what you have is your function A. Finally you have got A is equal to pi square r square into h square plus r square. So what we are going to do is we have to make use of this relation here. So what I am going to do is you try to write h in terms of r. So this is from this relationship 1, we are going to have this h square is equal to k square, this 3 goes up, so 9 by pi square into r power 4. We have got it from this, cross multiply and square it. Now I am going to substitute it here. So when I substitute in this result, what do I get is A is equal to pi r square. You should be careful because you may have some slips here and there, and that will create a lot of trouble later on. So usually students commit mistakes, a lot of mistakes while simplifying this. We do it very slowly, we'll do it right. So get it inside. So what you get is 9k square. One of your pi is out. I think you have got pi square, yeah. Pi square is going to be off. You're going to have just r power 2, and then when you multiply this inside, it's pi square into r power 4. So this is your final function entirely in terms of a single variable r. Now what is the condition for the least value of A, that is the minimum value of A? So just specify it. A is minimum or least if A dash is 0 and A double dash is positive. So that is the condition for minima for a function. So now we shall differentiate it. What do you get for A dash? Or if you don't want, you write it as dA by dr. R is a variable here. it is 9k square. 9k square. When you differentiate 1 by r square, it is minus 2 by r cube. And this one is very easy to differentiate, 4r cube. Now this is minus 18 k square by r cube plus 4 pi square r cube. So now I am going to have my second derivative here itself, because you can't, it's better you complete it here, it will be very easy for you. A double dash. So what will you get when you differentiate 1 by r cube? See, k is a constant, your r cube is a variable, it's in denominator. When you differentiate 1 by r cube, the result is minus 3 by r power 4. If you are sure about this, then you can proceed. So then you will get minus 18k square into minus 3 by r power 4. And thereafter the next term is, this 3 comes down while you differentiate, it's 12 pi square r square. So the beauty about this a double dash is, it can never become negative, because see, all your powers of r are even. So no value of r will make it negative. No real value of r will make it negative. So absolutely this is going to stay as positive always. So you cannot have a maximum here. You can only have a minimal value of area. This is always minimum. So it's very easy to go about now. So now this is your second derivative, which is greater than 0. If you want, you can specify it is positive always. So you can even say a is minimum for all r. Here itself you can specify this, that your a cannot become a maximum. It is also, if at all is going to become anything, any extremum, it will be a minimum always. So next step is, now you equate your derivative to 0. So what was your derivative there? Your a dash was minus 18k square by r cube plus 4 pi square r cube. Now when you equate this to 0, what's going to happen? You're going to take this term to the other side. So finally you will be getting 18 4 pi r square onto one side, r cube, and 18k square by r cube. So finally when you simplify this, your r power 6 is 9k square by 2 pi square. So this is what you get for r power 6. And do we need to find this r? No, that's not necessary, because you see, your a is always minimum, as you have mentioned previously. If at all you want to do anything, you can just take a square root of this and you can write r cube. So you can just specify, when r is equal to the whole power 1 by 6 of this expression, namely 2 pi square, this a double dash is positive. We have mentioned this already. Just make a note of it to claim your minimum. A double dash is positive. That implies your a is least when your r power 6 is equal to 9k square by 2 pi square. So this is what we have got now. So writing this is same as writing the other one. So from where did you get this result? And that result was by equating this a dash to 0. So now we have shown that your surface is least. Actually a is square of the surface. So this a shall be the least. Automatically your surface is going to be least. So what your a is, it's a square. So when your square is minimum, this quantity s is going to be minimum. That we have mentioned already. So this a is least when this is going to happen. So now what you need to show is the relation between the height and the radius. That is what he has asked for. He has asked us to prove height is equal to root 2 times of the radius. So where is that relation you have for your h and r? It is here, we have written it already, and that was okay. So you can just substitute it here. How do we substitute it? It's better you do one thing. You can't substitute for r. It's easy to substitute with your 9k square. So what you write is 9k square is equal to 2 pi square into r power 6. So when I substitute in that relation, which I shown already in your step, if you want you can specify it as 3, and substituting in 3, what was your 3 there? It is h square equal to 9k square by pi r power 4. So when I substitute for 9k square here,